morning and welcome back to Brodeur Land. It is day 5 of week 3. We've made it to the end of week 3. We're about to roll into spring break, and come on guys, it's Friday, Mr. Brodeur's favorite day. So let's dive in, let's wrap this up so you can finish off math before spring break and get ready to roll. So day 5, we need to create and solve 3 equations with variables on both sides. One has to have one solution, another with no solution, and the third one with infinite solutions. And then afterwards, you need to write a letter to a fellow student explaining how you would solve the equations and how you know what the solution is. So let me come over to the whiteboard. I'm going to create 3 with you. So these are going to be 3 equations that I create. And I'm going to show you an easy process to guarantee that you get all 3 scenarios, okay? Infinite many solutions, if you remember what infinite many solutions or infinite solutions are, that's pretty much where the equation looks exactly, or the expressions look exactly the same on both sides of the equal sign. For example, I'm just going to make up this. I'm going to call the left side of the equal sign 2x plus 3. Well, in order to guarantee that you have infinite solutions, you also need the right side to be the same. Boom, right there, I just created myself an infinite many solutions equation. Now, remember, if you want to go about solving this, all you need to do is get your x's to to one side. So I'm just going to pick an x. I'm just going to move this 2x right here. And remember, since we're going to the other side, since we're crossing over the equal sign, we have to do the inverse operation. So I'm going to subtract 2x to both sides. Now, what you might see though is that 2x minus 2x and 2x minus 2x both gives us 0. So we have no more x's left. And what you might remember back from class when we did this is when you have no x's left, you're trying to see, is my statement true? Does 3 equal 3? And of course 3 equals 3. So that would be good. And that would be an infinite solution scenario. Now, going further, let's talk about no solution. I'm still going to kind of use this equation, but I'm just going to alter it slightly. So I'm still going to start off with 2x plus 3. The difference is, clearly with no solution, we don't want the same thing on both sides. However, you do want one thing that's the same. You need your x to have the same coefficient out front, which is my 2. So notice they still have 2 x's. However, I need a different constant. I have a 3 on this side. My constant on this side needs to be a different number. So I'm just going to use 4. If you want to get crazy and do -5 or 100 or 123 or whatever the case may be, that's fine. But I'm just going to keep it simple right here. Now, what we need to do is go about solving this. So just like what I did with infinite solutions over here, I'm just going to try to get x's to one side. So I'm going to just subtract my 2x to both sides. That will again eliminate my x's. I have no more x's left. And we get into this weird scenario where like, oh no, the x's are gone. So do we have a true statement right there? Well, clearly 3 does not equal 4, which indicates that we have a no solution right there. So boom. Well, maybe I shouldn't put an x there because I don't want to confuse you guys. But clearly 3 does not equal 4, so we wouldn't put a check mark for it being a true statement. All right, last one, we got one solution. Again, I'm going to stick with my 2x plus 3 just to kind of make things a little bit easier creating these equations. Now the key here is, with one solution, you do not want your x's to have the same numbers out front. You don't want them to have the same coefficients like we did here. So I'm just going to alter it slightly. Let's say we have maybe 3x. That might be a different number. So that way my x's don't have the same numbers out front, the same coefficients. Now my other numbers can be same or different. So I'm just going to stick with the plus 4 from before. You can choose a different number. You could have them both be 3s. That's fine. The big thing on one solution is your x's have to have different coefficients. That's the main thing on this. And then you're just going to go about solving it. Now remember from class, you usually want to move whichever is the smaller of the two x's. So 2x is clearly smaller than 3. So I'm going to subtract 2x, do the inverse operation. All right, those 2's get eliminated. We got 3 right there. That leaves me with 1x plus 4. And then last, we just got to solve for x. This is a one-step equation at this point. So I'm just going to subtract 4 to both sides. And that gives me x equals, and then this should become -1 right there. And then you get your one solution because we only got one number that equals x right there. So this is my example of infinite solution, no solution, and one solution. I'm hoping by showing you how I set these up, this will give you a better idea of how you can create your own equations. So all in all, what I'm hoping is that all these videos this week really helped eliminate some stress for you guys and hopefully made this an easier process to finish and wrap up week 3 assignments. But just let me know, especially with spring break right around the corner, let's wrap this stuff up. Send your questions, get this turned in so you don't have to do anything next week. Remember, this week coming up, spring break, you have no assignments. So your next set of assignments for week 4 will be after spring break. But I'm always here for you guys. Send me your emails. I'll be glad to answer your questions. But until next time, Brodeur out. Peace.